Good noontide from balmy Honolulu. My name is Howard Wigg, Hawaii State Energy Office, and welcome to Building Energy Education Fundamentals. This webinar will be followed next week and a week after that with two more energy-related webinars. So welcome 213 of you. You have set a new record. First, logistics. Yes, the webinar will be posted on the Hawaii State Energy Office website, and you're welcome to take as many copies as you want. If you want a certificate of attendance, just contact me and I will get one to you. Very important, post questions on the Q&A site. We will attempt to answer all of them during the program. If we don't get to all of them, we will contact you later with the answers. And the bathrooms are right down the hall, ladies on the left, gents on the right. Now, before I begin to introduce the charismatic cast of characters, let me remind us all that Hawaii was the first state in the nation to declare 100% clean energy, and then we ramped it up to a decarbonized economy. Why are we doing this? We all know, you're a sophisticated audience out there. We all know the usual reasons if we want to hand down a habitable planet to our grandchildren, we need to decarbonize very rapidly. But there is one more reason. I recently attended the Honolulu Symphony, and the conductor asked us all to rise. And suddenly, on the big backdrop, there appeared yellow and blue. It was the Ukrainian flag. And the orchestra played the Ukrainian national anthem. They got a thunderous applause. And this type of thing is being replicated throughout the nation. This gives us one more reason to decarbonize. Russia is the world's largest exporter of fossil fuel, and the sooner we get to 100% clean energy, the more we are in control of our destiny. It's one more heartfelt reason for decarbonizing the economy. Now, nationally leading the charge towards clean energy is the US Department of Energy. In fact, her grant is the reason we are here today. And to welcome us to this session all the way from Washington, D.C. is Mr. Christopher Perry, engineer with US DOE. Welcome to balmy Honolulu, Mr. Perry, and please take it away.
Great. Well, thanks for the introduction, Howard. So I appreciate you letting me say a few words here. So like Howard mentioned, I'm Chris Perry from the U.S. Department of Energy's Building Energy Codes program, which is part of our Building Technologies office. And yes, I'm not in Hawaii. I'm located in Washington, D.C. So it is 6 p.m. here. Our program here, the Building Energy Codes program, is we're involved in a lot of different aspects of energy codes, and that ranges from helping develop energy codes at the national level to providing technical assistance to support cities and states, when they're looking to adopt or considering adopting a new code. And one area that we see is absolutely critical to the success of our program is to help support trainings and developments in workforce on energy codes. So that could include, building science and emerging construction practices, new technologies, really anything related to the construction of new buildings. So we think programs like this are critical to helping us implement advanced building energy codes. And I'm, definitely biased because I'm in this field, but I think this is a really great field to be in. It's an area where you can have a major impact on energy and carbon savings and saving money for building occupants on the utility bills. And it's actually fairly cutting edge. So codes are starting to embrace technologies like electric vehicle charging infrastructure, solar, photovoltaics, energy storage. And these types of technologies are currently, and they're going to continue to be a critical part of the buildings industry. I also mentioned that there's quite a bit of job security in this field, just looking at how many folks are going to be retiring in the next few years, and how much new construction we have going on. So we're really excited about this program and for its potential to hopefully expand even beyond this program to other community colleges and have a lasting legacy after our funding expires. And we think it's also really great that you can have this sort of training to focus exclusively on Hawaii, which has, obviously a very unique climate and building stock when compared to the rest of the US. Really, like a one-size-fits-all training program just wouldn't be as useful to everyone here. But now you really get the opportunity to dive into Hawaii's unique challenges and opportunities. So really, that's it. Wanted to say welcome and hope you feel like you really get a lot out of these trainings. And we hope you're also excited about the opportunities that we have with buildings. So thank you.
Thank you, Mr. Perry, traveling all this way from Washington, D.C. Eric, if we could go through, yes, the AIA slides. Yes, there's a lot of architects in the audience, and yes, you will be receiving your educational certificates, and you've all seen these slides before. It's standard operating procedure for AIA credits. And here are our presenters, myself, Chris Perry. I'll bring up Sumi Han in about 30 seconds, followed by Norman Takea, HCC, and then Eric, and then Justin. I'll be introducing the people in the order in which they appear. So if we could go to Sumi's slide. Oh, this is the program status that we'll be going through. Oh, and the very most important thing right at the last, you have to stay till the end, Zippy's cards. So now let's bring up Sumi Han. We mentioned that USDOE gave a grant. Well, the person who wrote that grant application was Ms. Sumi Han, University of Illinois, Smart Design Energy Assistance Center, or CDAC. And Sumi is the omenons grise behind this whole effort. So please, from Chile, Illinois, please take it away, Sumi.
Thank you, Howard. Here right now it's a 43-degree and it's cloudy. So I really want to be in Hawaii, but somehow we decided to through Zoom. So thank you so much for the introduction, and thank you so much for giving me an opportunity to present the B Fundamentals program overview to you. Next, please. So as Howard said, my name is Sumi Han, and I'm from the Smart Energy Design Assistance Center, in short, CDAC. CDAC is an applied research program at the University of Illinois at Urbana-Champaign. We have been working in energy efficiency field about 15 years, and our sponsors and partners include federal agencies such as DOE, US EPA, and state agencies and utilities, municipalities, and private firms. Next. And for this program, B Fundamentals, CDAC has partnered with state energy offices in 3 states, Illinois and Hawaii, you guys, and Nevada. And as you can see from this list, we have many collaborators and participants of the program from many different fields. And to name a few, our participants are from community colleges and universities, K-12 schools, municipalities, building departments and economic development department, and also state agencies and utilities, design firms such as architects and engineering firms, and construction companies and contractors, and also professional organizations. So we do have a lot of participants and collaborators in addition to our 3 energy offices partners for this program. So we are very excited to meet with you all today, and also we have more events coming up, so hopefully we can see you later on. Next, please. So what is B Fundamentals? We came up with this cute logo. I hope everybody likes it. And B stands for Building Energy Education. And internally, we do have B Fundamentals, and also we have B for Architects series too. And anyway, this program introduced, the college students and young professional, and even, other professions, doesn't need to be young and student, and to teach energy efficiency and energy code topics to prepare them to integrate energy efficiency into their work. That is what this program is about. So there are two goals of this program. One, the goal of this program is to increase participant knowledge of energy efficiency and energy efficient design and construction practices. And we're saying something like teaching energy efficiency through energy code. That's one of the goals of this program. And second goal is to increase awareness of employment opportunities in energy efficiency and code professions. Next, please. So careers in energy efficiency, this graphic shows a range of different energy efficiency jobs. The jobs with dotted outlines are jobs that are relatively new. For instance, like commissioning services, auditing services, energy modeling, and building automations. And the jobs that have solid outlines are jobs that have existed for a long time, but have become more energy efficiency focused, such as engineers, architects, and electrical contractors. And so this chart actually emphasizes that energy efficiency jobs cover a wide range of industries, skills, employers, and sectors. Next, please. So this slide, we're trying to show that whatever the interests or skills individuals may have, there's probably a place in the energy efficiency workforce for them. And here are some examples of different skill sets that connect well to the energy efficiency jobs. Building related jobs, policy planning, analysis and computation, financial and customer service and training. And we're going to talk a little bit more about building related jobs and some non-building related jobs in next few slides. Next, please. So careers in energy efficiency. Buildings consume about 40% of energy use in the US, and the average buildings have potential to reduce about 30% of that energy use with the cost-effective improvements in energy efficiency. So building related jobs has really tremendous potential for energy efficiency. As technology improves and policy efforts invest in energy efficiency, that fraction will likely increase. So it could be 40, 50, 60%. This opportunity represents a huge amount of work that needs to be done. So from design to maintenance and operation, these building related jobs represent a range of skills from all analytical and remote to all hands-on and on-site. Next slide, please. So not only those building related jobs, there are also non-building related jobs or non-construction careers in energy efficiency, such as program implementation, especially for the utility companies, and product development in cutting edge technologies, and also public works such as the water treatment and public transportations. Those careers, we all see it's under the energy efficiency umbrella, and those people who are interested in pursuing careers in these sectors should know about energy efficiency and energy code. Next, please. So not all energy efficiency work is actually technical, as you can see here. Sales and marketing, program management, and policy making. And actually, it takes a lot of outreach and education, such as our program here. This is mainly a little bit of research, but a lot of education and outreach. Next, please. So those are, general energy efficiency related careers. But how about building code officials? The career as a code official. We thought, this is a very interesting, data. So the data are from ICC report. It's called The Future of Code Officials. And the figure on the left that shows that 82% of code officials plan to retire in 15 years. So that means that there's a lot of opportunities for young professionals or people who are considering the second job. There are a lot of opportunities in code profession as a career. The figure on the right shows the reason for pursuing a career as code professional. And the number one reason was job security, which is a very important factor. But I think it's interesting that 36% of code officials chose that the respect for the profession as a reason for pursuing code professional careers. So it helps environment, it helps people, and also you get respect from fellow professions and the industry people. So we think that's very interesting fact that probably you didn't know about it before, about code professional as a career path. So we just wanted to share that information with you. Next slide, please. And these are quotes from the same report. And the question that they asked to code official was, what advices do you want to give to young professional? You already, code official working in this field for some time. Are there any advices that you want to give to, young professionals? And they said, it's extremely rewarding job. It's always helping people, always learning, never a dull moment, always in demand. And also one code official said, his experience as apprentice, journeyman, and foreman and supervisor really served him well to be code inspectors. So, there are not many code officials who started as a code official. They started as a contractor or architect or engineer, and then they become, a code official. We see a lot of code official kind of evolved from different professions. And also one code official really emphasized the education and training. You need to have a good understanding on how buildings work and how structures work. And you need to, train yourself and get a lot of, you need to take advantage of a lot of education opportunities to be a good code profession. Next slide, please. So with all those information and careers in energy efficiency and building codes, why this BE fundamental program is needed and why it is important. So we interviewed code professions and community college instructors and energy efficiency industry professionals. And these are the quotes from our interviewees. And they said, we're going to keep struggling with code compliance until energy code training permeates the building trades all over, because it's not, it cannot be done by one profession or, just two professions. It just takes all. And, one instructor said they cover some basic knowledge, but they want to focus more on energy code and how it relates to other principles. And one consultant said it emphasized the importance on hands-on experience or see live examples. And that's why our curriculum try to kind of address that and try to include a lot of photos and also videos, so it could be as close to the hands-on experience and live examples. Next, please. So this is our program webpage. If you come to this program webpage, I think somebody could drop down that link to the chat box, or if you could come to CDAC website, there's a Be Fundamental program, and it has lots of good information. And especially, I want to just talk about two things. So one, it says instructor toolkit, how to use our curriculum. And second one is access to our modules. This is access to our Moodle site. Moodle is like a platform, educational platform that you could download or access lots of materials and resources that we have provided there. The next slide. So if you click the instructor toolkit, this is a part of the instructor toolkit that you can find. You can find some information about the program itself, and also you can find information how to use our curriculum. So there are some Q&As, such as what is this program about, and how can I be involved and get updates? How should I select which curriculum to use? Can my students work through the materials on their own? How can I provide feedback? So this is a snapshot especially for the instructors, how to utilize our program materials. And next, so if you click the access to Moodle, and you can have access to all the materials that we have provided for free. And next, please. And now we're gonna watch like a 2-minute video together. And if you could increase your volume of your device, probably it'll be helpful because the audio of the video is a little bit soft. So let's take a listen.
Thank you for your interest in our Building Energy Education Fundamentals, or B Fundamentals program. This video explains how to access and use our educational materials. You will need to create an account to access the materials. Signing up is quick and easy. Click on our Moodle page to get started. Be sure to indicate whether you are an instructor or student. We have special instructor-only resources. Our curriculum is free to use. There are 4 groups of modules in our B Fundamentals program. There are 4 intro modules. In our last group, Advanced Modules, there are 3 modules: Beyond Code, Net Zero Buildings, and Existing Building Renovations. Now let's take a look at an example module from our Envelope group, Envelope and Insulation Fundamentals. For this module, there are 3 subtopics as well as activities, which include worksheets, a Jeopardy game, and other activities. Let's take a look at the first subtopic in this module and see what it contains. Here's where you will find the presentation slides. The PowerPoint is for instructors and the PDF is for students. The PowerPoint instructor slides contain detailed lecture notes and context for the slides that will be helpful. Activities for this module are located in a special Activities folder. Worksheets can be assigned as homework or in-class activities. We've created a review game based off the popular TV show Jeopardy! This is a building control layers activity where students are encouraged to practice reading construction drawings and identifying control layers. There's an online quiz that students can take to demonstrate that they have learned the material in the module. Students who receive a score of 70% or higher receive a certificate of achievement. Have questions about our curriculum or how to use it? Check out our Q&A page where we address common questions including what this program is about, what kind of content we include, how you can use the materials, and how you can contact us if you have questions.
Next slide, please. So that's that shows you, a little bit of how you can navigate. I thought it would take time for me to navigate, on spot. So we just filmed a little video to show you how to navigate the Moodle, where you can find a lot of resources. So Hawaii event today is one of the many, program launch event that's happening throughout 3 states. And, if you want to check out what's happening in Nevada and Illinois, you're welcome to come to our meeting. Also, if you are instructors or, training providers, we highly recommend that you come to our Train the Trainer workshop that's going to happen on April 29th. So with that, I think next slide. And if you have any questions about the program in general or anything that I said, please contact me. And this is my email address. And thank you so much.
Thank you so much, Sumi. If there was ever a growth industry, it is achieving 100% clean energy, not just in Hawaii, but nationwide. And I might mention that these are good paying jobs. Example, Mr. Uchida, the head of Honolulu's Department of Planning and Permitting, recently declared that he will be looking to hire over 100 plan checkers and inspectors. Good, solid government jobs with all the benefits there. Speaking of good, solid government jobs, one such holder is Dr. Norman Takeya, engineer and instructor at Honolulu Community College. Welcome to our August event, Dr. Takeya, and please describe your role in this enterprise.
Thank you. My name again is Norman Takeya. I'm an assistant professor, Honolulu Community College, in the Architecture, Engineering, and Construction Technologies program. We've been involved with CDAC curriculum for about 2 years now. And we began incorporating some of the curriculum into our courses last fall. And now we're going to probably expand it to include it into all of our classes due to changes that we're making in our program right now. We're going to do some major program changes next fall. So incorporating the CDAC curriculum will be really helpful. Good curriculum is hard to find. Good curriculum is hard to create or develop. And the curriculum that CDAC developed is not only good for us, it's ready to deliver. So it won't take much for us to incorporate it into our classes. For architects or practicing professionals, you can use the curriculum for brown bag lunches to train existing staff in-house is a good way to do it. You really need to look at what they've developed and see how you can incorporate it into what you guys are doing. As far as the colleges, Maui College has a lot of energy related programs. We're not quite there yet at Honolulu, but we are moving in that direction. There's a big push now to develop non-credit courses to help, I guess, adult learners and educate adult learners in different areas, and energy is going to be one of them. All I can say is you guys really need to look at the curriculum and see how you can use it. It'll help. Howard has talked about DPP. We have an internship agreement with them and already placed 4 students this year into plan checking positions or on the track to a plan checking position. So the need is there. Unfortunately, I don't have the number of students that I need to fill out the positions available. But hope you get something out of today's workshops, and like I said, try it and see if you can use it. Thank you.
Thank you for those words of encouragement from your boots on the ground position, Mr. Takea. And in terms of the core presentation, gives me great pleasure to bring up the star of the show today, Mr. Eric Kolderup, professional engineer and energy consultant who has been with us, I hope you're sitting down, since he developed Hawaii's first residential energy code in, drumroll, 1994. He's been with us on and off ever since, and he is the star of the program today. Please take it away, Eric.
Thank you, Howard. And I guess to the audience, if you all don't know Howard already, you now know that he's prone to hyperbole, but appreciate the introduction, Howard. So today, well, for the next bit of time here, I'm going to provide some highlights from several of the modules that Sumi just described. So the first one will be some of the building energy fundamentals and envelope modules. So first we'll cover some building energy fundamentals and then some of the envelope modules. The goal here is to share some useful information today, but there's a lot there that we can't get through, of course. So I also want to give you the taste of what's there and inspire you to check out the full modules for more details on the topics that you find interesting. So the first one is Module 2, Part 1, Understanding Energy and How It Moves. So one basic concept that I know a lot of us are familiar with is the relation between energy and power. So power is the rate of energy flow, and it's equal to energy divided by time, right? And then another way of looking at that is that power times time equals the energy used. So a kilowatt is a common unit of power, of course, especially used for electric power. And if we have an appliance that uses 1 kilowatt of power and we run it for 1 hour, then we have consumed 1 kilowatt hour of energy. Now, this may be obvious to you, but it's pretty common that people get these terms mixed up. So now you know. And in this country, we use some funny terms for energy and power, for better or worse. So I encourage you to check out this education module, to help explain some of these terms like BTU, which is the British thermal unit, or cooling ton, which have physical or historical significance, but can be quite confusing. There's also information about the conversions between these different units, like between kilowatt hours and BTUs. So then another aspect of the fundamentals is heat transfer. So knowing a bit about heat transfer can help us to understand and evaluate different insulation systems and different energy systems in buildings. So here are 3 factors that affect heat transfer: the temperature difference, the time over which heat transfer occurs, and then the area over which that heat transfer occurs. So the greater the temperature difference, the greater the heat transfer. And we're often talking about the difference in temperature between indoor and outdoor temperature. So this graph, is showing 70 degrees inside and 0 degrees outside. That's not so applicable to Hawaii, of course, but you also get heat gain, of course, when the temperature outdoors is higher than the temperature indoors on a hot day. So the greater the time, the greater the heat transfer. So if you have a rate of 100 BTUs per hour of heat transfer, then over 3 hours, you've accumulated 300 BTUs, of course. And then the larger the surface area, the more heat transfer. So if you have twice as much surface area, then you have twice the rate of heat transfer. It's a very simple relationship. So then how does that heat move? Well, it moves through space or through building assemblies like a wall in 3 ways: by conduction, convection, and radiation. And all three of these will happen in buildings. So in this second module, or sorry, part 2 of this module, there's more information about these methods of heat transfer. So first, let's talk about conduction, right? So this is heat moving through a material or through materials that are in direct contact with each other. I think we've all experienced conduction, right? And then different materials have different thermal conductivity. If we had time, we could talk about ranking all of these materials, but I think that we all understand that some materials are good conductors of heat, like metal, or in that other materials have low conductivity and are useful for insulation. So we take advantage of these properties as appropriate. And then these infrared images can be useful. So they can help us see the difference in conductance of different parts of a building envelope. So the one on the left is a picture of a house in a cold climate. And what it shows us is that the windows and the doors appear to be warmer because they have a higher conductance than the opaque parts of the envelope. The image on the right, this is interesting because it's on the inside of the wall, and what you can see is that the framing shows up cooler than the rest of the wall. So there's heat that's conducting through the framing more rapidly than through the cavities. And remember that when we talk about thermal bridging in just a minute. So how do we measure conduction? So a material's resistance to heat flow is defined as its R value. So here you see R13 printed on batt insulation product. Of course, the higher the R value, then the more insulative the material is. And then to calculate the heat flow through the envelope, we define the U value, sometimes also called U factor, which is the thermal transmittance of an assembly, like a wall or roof. And it's the reciprocal of the R value, or 1 over the R value. So in this case, the lower the better for reducing heat transfer. So an assembly that has an R value of 1 has a U value of 1. R value of 4 is equal to an R value, a U value of 0.25. So it would have 1/4 the amount of heat transfer as the R1 material. And then here you can see there's information about typical building material R values. So for example, if we look at fiberglass batt, for example, it's about R3 per inch. So if we had 8 inches of fiberglass batt, that would get us somewhere around R24, maybe a little more. By contrast, if we looked at 8 inches of concrete, that's only R0.64. So clear to see the difference in conductivity between concrete and fiberglass batt insulation. So then if we want to calculate the rate of heat loss from a building, or I guess more importantly for Hawaii, the heat gain to a building when it's hot outside, we can do that if we know the U factor of the construction, the area of the surface, and the temperature difference between inside and outside. And then if we consider a period of time, we can calculate the total amount of heat that passes through the wall or window or roof. So the formula is here. That's the U factor times the area times the delta T, difference in temperature between inside and outside, times the time. And if we use these units here, we get Q, or the heat transfer, in terms of BTUs. So that's a bit about conduction. There's a lot more information in the modules that I encourage you to check out. So the second type of heat transfer is convection. And one example of convection is infiltration caused by wind pressure. So in Hawaii, for an air-conditioned home, warm, humid air that leaks into the building adds heat to the space and increases the energy consumed by the air conditioner. So that's unwanted infiltration, adds to the energy use. To reduce unwanted infiltration, it's important to pay attention to good air sealing practice. There can be a surprising number of holes in a house, especially in places that we can't see, things that get covered up when the wallboard is up. So points where the wiring and pipes penetrate the envelope can add up to a significant hole. So here you see that there's been some foam sealant applied to those holes to help reduce air leakage. And if you have an air-conditioned house, these leaks can increase energy use, of course, and they can also potentially cause moisture problems when that warm, humid air leaks in and might come in contact with a cool surface. And here you can see an example of unsealed penetrations. So there'll be all sorts of wire and pipe penetrations and potentially duct penetrations and others that go through the ceiling. And like I said, these can add up to big holes if we don't pay attention to them. And then there's radiation. So this is the third heat transfer mechanism. And this one's especially important in Hawaii, like sort of warm climates like Hawaii, because it can affect our comfort as well as our AC energy consumption if we have an air-conditioned building. So the radiation from the sun, of course, it heats the surfaces of our buildings, and those warm surfaces conduct heat through the walls and the roof. So that increases cooling load. A portion of it, the radiation also passes directly through windows and heats the spaces directly. So those are two paths that the sun's radiation takes to get into the building. There's also radiant heat transfer that happens inside the building. So when the roof is heated by the sun, it re-radiates heat down onto the ceiling below. So that's one path, like more than half of the heat getting through the roof and the ceiling is due to that radiant heat transfer between the roof and the ceiling below. And the warm ceiling then radiates heat onto the occupants below and affects our comfort. So understanding the impact of this radiant heat is useful for identifying good strategies to keep homes cooler, such as things like reflective exterior surfaces or shading your windows from the sun with overhangs or other kinds of shading devices, especially valuable in Hawaii, right? And the thing that makes radiation different from conduction and convection is that there's no contact between the warmer object, such as the sun, and the cooler object, meaning you. You are all very cool. The conduction, on the other hand, is through direct contact with materials, and convection is transferring heat from one object to another with, due to movement of a fluid such as air. So that's our conduction, convection, and radiation fundamentals. This is an impact of example of the impact of solar radiation. So this wall is absorbing some of the radiation that hits us, and it's heating up higher than the air temperature, so 132 degrees. And then this darker wall in the sun is at 171 degrees. So it has a lower solar reflectance than the previous case. So you can see that surfaces in the sun can get really hot. So a good strategy to keep a home cooler or any building cooler is to use exterior surfaces with a high solar reflectance. And that's why you see some roofs with white coatings. They reflect a large portion of the sun's radiation and they keep the surface much cooler. And then radiant barriers. So when we understand radiation, we can understand the benefit of a radiant barrier. So this example is a foil sheet that's laminated to the bottom of the roof decking. And this material has a property called a low thermal emissivity. And that property represents how much heat it radiates when it gets warm. And with this radiant barrier, when the roof gets hot in the sun, which it will do, it will radiate less heat onto the ceiling below. So the ceiling stays cooler. And if you have air conditioning ducts in the attic, then those will also stay cooler. So radiant barriers are a very useful strategy in Hawaii. All right, so that's a little bit about fundamentals. I'd like to give a quick tour, if it's okay with you, on this module 5, where the part that talks about air barriers and thermal bridging, because thermal bridging is a very important topic. So thermal bridging happens when you have a framing material like wood shown here that has a lower thermal resistance than the insulation. So here the wood equals about R5, the insulation about R13. So that framing causes the overall performance to be somewhat worse than just the insulation alone. Now with wood framing, it's not a really big penalty. And so this example here actually would comply with the energy code in Hawaii for homes. But if you have metal studs, which is pretty common in Hawaii, that high conductivity of the metal makes the thermal bridging much more extreme, and it cuts the effective R value of the wall by more than half. So instead of getting an R13 wall, you're maybe getting like an R6 wall. So what do we do about that? Well, one solution is to try to add thickness. So here a 2x6 frame instead of a 2x4 frame. But if you have metal studs, that doesn't really help all that much. So with metal framing, a more effective solution is use continuous insulation. So in this example, there's an R5 layer of rigid insulation that's attached to the outside of the framing. And as we'll see in a minute, it's commonly used. We commonly use rigid board insulation, foam board, for this continuous insulation layer. So that's a quick tour on thermal bridging. Not as important or not as big of an issue in Hawaii compared to, say, Chicago, but still has a significant impact on heat transfer, and it's important to pay attention to. All right, so then there's unwanted infiltration. I mentioned infiltration earlier. So an important function of our building envelope is to limit unwanted infiltration and exfiltration. So I encourage you to check out this module online. There's a lot more discussion about the envelope as an air barrier and how to define where your air barrier is in an envelope. But this chart shows that there can be lots of different sources of leaks. And as I noted earlier, these can add up to a big opening if you don't pay attention during construction. So why, do we really care about leaks in Hawaii? Like I mentioned, this isn't Chicago. It's not 0 degrees outside. You don't have 0 degree air leaking in. Why is it important? Well, in Hawaii, more and more homes are getting AC and being built with AC. And air leakage in an AC home can cause two problems. One obvious one is wasting energy. You have to use more cooling energy. The other is moisture damage and mold growth. So if you have that warm, humid air coming in through cracks in the envelope, when that air comes into contact with a cool surface on the inside of a wall, for example, there's the potential for condensation and mold growth, and we obviously don't want that. So helping to control infiltration reduces the chances of that happening. Now, some of you have probably seen a blower door. We can find many of the leaks using a blower door. So this is a fan, as you can see there in the picture, that is installed in a doorway and that sucks air out of the house and measures the airflow that you get as a representation of how leaky the house is. Then you can go around and find where the air's coming in and hopefully identify and fix the leaks. So as this slide says, this testing is required by the energy code for low-rise residences, so for homes and residences up to 3 stories, though some Hawaii counties currently make that testing optional. Okay, so that's thermal bridging and air barriers. So are you up for taking a quick tour of walls and windows? Obviously you don't have much choice, but so I'm going to dive into it anyway. So if you check out the online education module, you'll see that there are several ways to insulate a framed wall. There are different materials, different types of insulation, and there are also different locations. And the choices, have both performance and cost implications. So you see on the left, bad insulation in a cavity. In the middle, rigid insulation installed as a continuous barrier. And then on the right, spray foam insulation also in the cavity. Each of these can be an appropriate solution, but again, they have different costs and performance implications. So I mentioned continuous insulation. So we classify insulation location as either continuous or cavity. So the idea is that the continuous is mostly uninterrupted by thermal bridges. And I say mostly because, there are often some fastenings, screws, or some other kinds of clips that are holding it in place that do create some thermal bridging. So we need to pay attention to how we're doing that. But in general, it's fairly continuous. And the cavity insulation is generally cheaper because you already have the cavity there. You just fill it with some insulation, but it, as noted, suffers from potential thermal bridging problems. Then there's windows. So when we look at window performance in a climate like Hawaii, as I'm sure a lot of you know, the most important characteristic is the solar heat gain coefficient, because we're usually trying to keep the sun's heat out of the building and avoid extra cooling energy. So the SHGC, it's a number that represents the fraction of the sun's total heat that makes it through the window into the space. And so in warm climates like Hawaii, of course, a lower number is better. And as we'll see in a few minutes, the energy code limit is 0.25 for air-conditioned homes. That means 25% of the solar heat gain that strikes the window makes it through to the inside. And for windows sold in the US, you'll often find a label with a rating from the National Fenestration Rating Council, the NFRC. This label shows the SHGC of 0.3. And in this example also has a U factor by coincidence of 0.3. So that's an indication of the insulating value of the window. And as we said, SHGC is usually something we care more about in Hawaii to help keep us comfortable and reduce our AC bills. But a U factor is important also. So like on a hot day, say it's 90 degrees outside, the heat's going to flow through the window from that 90-degree temperature outside to say you're 75 degrees inside. So a lower U factor means a lower rate of heat gain and again, lower AC bills. So both are important, but really pay attention to the SHGC. And then finally, for envelope, we've got roofs and ceilings. So just like with walls, there can be different locations for the roof insulation depending on the type of construction. So the roof exterior surface is always the bulk water control layer, right? But the thermal layer and air control layer can be at a different location. So for commercial buildings with a flat roof, insulation is often above the roof deck, like you see on the left. For cathedral type ceilings, it's common to use bad insulation in the cavity, but you can also use foam board up above. And we'll look at the attic insulation options on the next slide. So traditionally we'd put insulation on the ceiling or the floor of the attic. So that's the thermal and air barrier. But more and more people are putting insulation up under the roof. That's the encapsulated attic example shown here. As far as the materials we use, so if we have insulation on the ceiling, then it's typically either loose fill or bad insulation. They provide similar performance. The loose fill is generally a little bit quicker and cheaper to install, so that might be a little bit more common. And then exterior insulation, that's typically foam board. The important thing to know there is that there are a couple different types of foam that are used that have trade-offs in terms of performance and water resistance and such. So check out the materials on that. And as I noted earlier, spray foam is becoming a little bit more common. This could be a bit more expensive than other options, but it provides some additional benefits. You get a little bit more indirectly conditioned space in the attic. And then also it provides air sealing, so it reduces air leakages much better than other types of insulation. So that's our quick tour of the materials you'll find on the Moodle site, related to building energy fundamentals and envelopes. So I suggest that you check out those. There's a whole bunch of extra material there, as well as the activities and the exercises that Sumi described earlier. Yeah, so now I'd like to take a few minutes to talk about energy codes. So there are a couple modules on the online Moodle site related to energy codes. We're going to take a quick look at the first two, 3.1 and 3.2. What are energy codes and standards, and what is the purpose of energy codes and standards? So first of all, energy codes are one of many building codes. There are also fire codes, mechanical codes, plumbing codes, which can vary from one county to the next, but it's one of many different codes that apply to buildings. So most building codes, they help protect the health and safety and welfare of the building occupants. So those on the left, that's their primary role. The energy codes are unique in that they're also there to help protect the building owners and users and tenants, save energy and money. And also, as we're more and more aware these days, to help mitigate climate impacts. Pretty much all energy codes apply to both residential and commercial buildings, and there are separate requirements for each type. And then they also apply to both new buildings and existing buildings. So for existing buildings, this can be things like an addition, right? That's kind of obvious that the addition needs to meet the code. It also can apply to alterations. So like if you add a new window, it may be that the new window needs to meet the performance requirements of the code. So it's not just new buildings, it's also existing buildings. And of course, energy codes include different requirements for different climates. So our requirements in Hawaii are for less insulation than would be required in wherever that is on the right, which looks very cold. And then finally, energy codes affect design and construction. So they cover the envelope, wall, floor, ceiling, doors and windows. They cover heating, cooling, and ventilation systems, and typically also lighting and water heating. That means there are some things that they don't cover, some things that use energy, like many appliances, refrigerators, cooking appliances, or all those things we call plug loads that are things that the occupants bring into the building and plug in. So in most cases, those are not directly covered by the energy code. And why should we care? Why do these exist? Well, as Howard mentioned, there are climate challenges facing us, and buildings make up a significant fraction of the total US greenhouse gas emissions. So energy codes try to contribute to reducing that fraction. They also help to avoid lost efficiency opportunities. It's always easier and much less expensive to build for energy efficiency from the start, rather than trying to go back after it's built and retrofit systems. So that's an important role of energy codes. And then finally, energy codes help reduce the financial burden on households. So in many cases, the amount of money people spend on energy bills is a big part of their total household income. And so the energy code can help mitigate that. Now, it's important to note that the energy code represents the minimum performance that is required by law. And there are opportunities to go far beyond it in terms of efficiency, but the idea is to help avoid the worst lost opportunities and the worst performance. And so I'm going to leave the B fundamentals modules now and just take a quick look at the energy code in Hawaii. In 2020, I guess it was, the state adopted the 2018 International Energy Conservation Code. And it also adopted amendments that add some flexibility that are appropriate for Hawaii's conditions. And then as we'll see on the next slide, in the state of Hawaii, each county goes through its own adoption process and may have additional amendments that apply to buildings in their jurisdiction. So this is the current status. State buildings are required currently to meet the 2018 ICC with state amendments, and Hawaii County has also adopted the 2018 with state amendments. The other three counties are still following the 2015 code, but they're facing a deadline of December this year to adopt the new code. There are links there where you can find copies of the state amendments, as well as a link to view the IECC online if you're interested. And so, this chart shows how the stringency has increased with each, 3-year update of the IECC. And it shows some dramatic improvements, right? These first codes were established around the time of the energy crisis in 1970s. And since then, there's been significant improvements in building performance. But this chart also shows that we still have a lot of work to do in terms of achieving better performance. All right, so you can get a feel for the energy code in Hawaii. I'll give a quick overview for low-rise residential buildings. In a minute, I'll show you links to some recorded webinars that have more details about both the low-rise residential and the commercial code requirements. So these are the things that are covered by the energy code. There are 4 compliance options. One that's really important for Hawaii is called the tropical zone option. And it applies if your building is less than 50% of the floor area air conditioned. Otherwise, there's a prescriptive path where there are tables of performance that you need to meet. Then there are 2 computer paths. One's called the simulated performance alternative, where you use a computer model to show your building's no worse than the standard reference design. And then there's a newer one called the energy rating index, which is also a computer method which rates the performance of your building compared to a reference and gives you a score. So you need to have an ERI of no greater than 57 for a home to comply in Hawaii. So you have some flexibility in terms of compliance paths that you choose. If you choose that prescriptive path, so for example, if you have an air-conditioned building or home, you would follow this path. This is some of the things that you'll need. R30 or greater roof insulation, the window, so heat gain coefficient of no greater than 0.25. You can see the requirements there for wall insulation, envelope leakage testing, which I mentioned, that's the blower door testing, and a number of other things, including, for example, duct air leakage testing. So that's pressure testing of the ducts to make sure that they're sealed reasonably well. You note that it also says point system allows some flexibility. So that's in the Hawaii amendments, and it gives you some alternatives for some of the envelope requirements, like you might be able to get away with R19 instead of R30 roof insulation if, for example, you used a cool roof, solar reflective roof surface. Now, if you don't need full AC, you can follow the tropical zone path, and the envelope requirements are less stringent. Leakage testing is not required. The big difference is it requires actual minimum opening areas for natural ventilation, defined as openings that are at least 14% of the floor area in each space. But it's a set of requirements that are pretty appropriate for many parts of the island where you don't need full AC. All right, so I know you want to learn more about the energy codes. First up, I encourage us to check out these checklists. So this is the residential checklist. It's available for download from the State Energy Office website. This is just the first page. It shows you the compliance alternatives. This is the second page that lists some of the requirements. So you'll see component like roof, what the requirement is, and in cases where there's options, it'll show you that there's options, lists the relevant code section, and maybe include some additional notes. And for those of you familiar with the 2015 existing code, it highlights in red the things that are changed in the 2018 code. So that can be very useful. And then lastly, I mentioned these 2 webinars. So if you go to the State Energy Office website, the link shown here, you can find 2 webinars from May of last year that provide more details about the code requirements, both low-rise and commercial. So I appreciate your following through that quick tour. Now, I'm going to invite Justin Beiser from Hawaii Energy to come online and talk about some example projects.
Great. I appreciate the opportunity. Thank you, Eric. So it's great to be here. We're excited to be able to share some of the programs that we've been working on, and I want to share some of the examples of those types of projects that I get to actually work within. If you're not familiar with Hawaii Energy, we, in simple terms, we educate, encourage, and we reward efficiency and energy saving decisions. And all of this, of course, is in pursuit of meeting our 100% clean energy goals. Hawaii Energy has been around for 12 years or more now, going on 13, I believe. And I've been around for about half that. So next slide, please. So just want to share some of the areas that I get to work within. So we have a variety of programs. I'm sure many of you have taken advantage of either instant savings by buying LED lighting at Costco, for instance, or have purchased a refrigerator and sent in your application form for your rebate. I work in more of the community-based energy efficiency area where we work in combination with a variety of partners, managers, et cetera, to get a lot of these things done. So the areas highlighted in yellow really are the projects that I focus most on. Multifamily properties, single family developments, and then for existing builds would be free home energy retrofits, as well as various appliance and water heating projects. Next slide, please. So just want to start off by kind of giving you an overview of our new construction program. So we try to work with developers early as we can. And essentially we reward developers for projects that exceed the current energy code requirements. And there's 2 approaches to that. So there's the whole building approach. This would be very early. And then of course the systems approach, when maybe the whole building approach wasn't deemed necessary. Next slide, please. So when we work with a developer using the whole building approach, we try to work with the design team as early as we can. And what we're able to offer that design team is up to $5,000 to incentivize them providing an energy model. Obviously, we can optimize a lot of things when we're early in the process. So if we can show that there's going to be incentive to provide this much efficiency in one direction, and they can take that savings and put it into additional efficiency measures throughout that design. So that's kind of the goal. Obviously, developers seeking maybe LEED certification, they would want to tackle this type of approach. And I know a lot of the new multifamily properties out there are really seeking that. I think as far as the opportunity wise, whatever's available in Hawaii, we have to, work with a variety of different areas. So I know there's a lot of architects here today, developers, and then a lot of students coming in. What we have to do is just continually find those counterparts that we can work well together with, and then find out how we can get in there very early, because we know those designs start sometimes several years before construction. So anyhow, next slide. On a simple approach, and I shouldn't say simple, but certainly far less complex, is our systems approach. And so when an energy model either cannot be provided, either due to the timing or maybe because the project simply didn't warrant one, we use the energy code standards and minimum requirements, and we're able to assess the systems that are going to be installed to find out what the KW and KWH savings will be on an annual basis as well as a lifetime basis to figure out what the incentive might be for that developer. Next slide, please. So if we're looking at a single family home, we'll work with a developer. They're going to build 10,000 homes throughout several years. And these requirements will change. So on a minimum level, our current standard is the home needs to have at least 85% LED lighting, and at least half of the appliances in the home need to be ENERGY STAR certified. So there's a few examples there, but these are custom programs. So if you meet the base requirements, then we can look at optional incentives on those. So that could be HVAC systems with a very high SEER rating, ENERGY STAR certified smart thermostats, whole house fans, and then custom energy efficiency systems that do exceed the code. So as an example, solar water heating on a multifamily project, which at the time wasn't required. Next slide, please. And so here's an example of a project that we're all very proud to have worked on. D.R. Horton built Kulia at Ho'opili, basically designed with efficiency lighting, appliances, HVAC, and solar water heating systems, all of which exceeded code for this multifamily property. Next slide, please. So Kulia is an affordable rental property. So it's very nicely appointed, especially if you've ever worked within affordable housing over the years. There's been many built. This is really by far one of the nicest projects I've had the opportunity to work on in that arena. So Mutual Housing is offering affordable rents, and because they designed the property or had the property designed with the solar water heating element in there for that multifamily complex, families get to enjoy savings on not only rent, but also their utility costs. In addition to that, they actually do have air conditioning. So I don't see a lot of that in affordable rentals. So that's a great project, and I'm very proud to have worked on that one. Next slide, please. So what did they save essentially? So estimated annual KWH savings for a unit, and there's 120 units there at Kulia, just over 3,000 KWH for that first year alone. And I pulled this excerpt here from the 2021 average from HECO's website. And so you can get an idea. It's estimated close to $1,000 savings per unit first year, just based on those energy measures that exceeded the current code. And over the lifetime, vastly more than that. So again, very proud to have worked on this project. Next slide, please. So I just want to shift gears here for a second and briefly discuss some of the programs that I get to work on that are for existing builds and more of community and event action type programs. So we feel to truly make an impact in a community, we have to collaborate, as I mentioned, with a multitude of partners, managers, vendors, contractors, property owners, and we might start with energy workshops. And then where I would come in is where we have our Energy Smart for Homes, which is a free in-home energy efficiency retrofit. At the time of installing those free measures, we are able to assess some of the additional systems in the home, such as refrigerator, washer, dryer, air conditioning, and water heating systems to see if they might be eligible for additional savings from some of the other programs I get to manage as well. Next slide, please. Okay, so this is an example of a project that I was able to work on this past year. we had what we call a community-based energy efficiency effort, so a CB effort. And this spanned Kolalo, which is basically 3 zip codes, more than 3,000 homes. In Kahuku Elderly Facility, it sits right there in the heart of it. And so next slide. Give you an idea. Yeah. So Kahuku Elderly, affordable housing community for older adults, as well as persons with disabilities. And you can see 64 units, they're offering 50% of area median income or lower, and the rents can't exceed 30% of income. So with projects like this, we get to come in and provide a lot of manpower, and we bring whole teams together in order to provide these energy efficiency efforts. Next slide, please. So first and foremost, at this location, we were able to do an education workshop we call Energy Unplugged. Residents, while they were at the community center receiving, having fun doing their unplugged, we were able to go in, retrofit all the units with the measures you see on the screen. So LED light bulbs, new high efficiency water measures, so shower heads, faucet aerators, and then we set up their advanced power management strips for their entertainment systems. So overall savings would be estimated about $160 a year as a free service that takes really roughly 25 to 45 minutes, depending on the size of the unit. Next slide, please. So how it works when we're able to get into a facility such as Kahuku, we go in, we retrofit, we provide the home energy assessment. So we'll look at the various other systems, AC, water heating, fridge, etc. And for communities such as Kahuku, where they would be eligible for additional subsidy from our programs, we could provide appliance trade-ups, solar and heat pump water heating type programs as well. Next slide, please. So what we were able to provide Kahuku Elderly was a refrigerator trade-up program. So of the 64 units, we identified 56 units that would be eligible for new Energy Star refrigerators. And we estimated the savings first year for all of the replacements at about 45,000 kWh. Of course, these are direct savings to those tenants. And over the lifetime of that unit, we're looking at about 380,000 kWh. And again, these types of efforts can't happen unless we work actively with our community partners. So starting with EAH Housing, Pacific Appliance Group, DSR, and refrigerant recycling, because we basically subsidize all or most of the costs to replace these refrigerators. In this case, it was all. And that includes purchase, delivery, removal, and the recycling of the old model. Next slide. So finally, I just wanted to share a few additional examples of some of the community-based energy efficiency efforts that we've done in the past. These 3 communities here basically were able to participate in all or most of the programs that I've just covered. And in this case, Kalihi Valley Homes, we not only did the Energy Smart for Homes, we also provided refrigerators, and then of course, the solar water heating tune-up. So this is a large project, and over many, many months, we were able to provide these types of efficiency efforts and measures. Molokai, that's same thing. We were able to start from the beginning and go through in Kunia Village, which is a facility that used to be the old pineapple plantation. So it was built for ag workers, and Hark is the management over there, and they worked with us to really ensure that the residents had opportunities to save, because we're talking about older plantation style homes. Next slide, please. So finally, just looking at the scope of these final projects, this is usually how we close out what our efforts are. So for KVH, 75 solar water heating tune-ups. In this case, we subsidize most of the costs on that. And then for Cunha Village, we actually were able to provide all 43 of those heat pump retrofits at no cost. So those were fully funded by Hawaii Energy. Same goes for Molokai on 29 solar water heating systems. So it takes a lot of collaboration and work, but it's vastly rewarding, and I'm just happy to be able to be doing these types of things. Next slide, please. So as you guys know, there's a lot to do. As Eric mentioned, there's a whole lot to do to get to 100% clean energy. But I think thanks to all of you and the efforts of the team I work with in the Hawaii Energy Program, and a number of other organizations like HSEO and B, I think we're going to get there sooner rather than later. And so I just appreciate you guys giving me the opportunity to share some of this with you. And feel free to, ask any questions you have, and contact me anytime if you have projects coming up in new construction or some communities that you'd really like to see us make an effort in. So thank you.
Yeah, so thanks, Justin. And we do have a few minutes here for Q&A. So as Howard mentioned earlier, if you've got a question, please type it into the Q&A box in Zoom, and we'll try to get to it. And I guess I'll just check in with others here, other panelists, to see if they're aware of any questions that have come up that we should try to address at this point.
There's been a number of questions, and we've answered them to the best of our ability so far. And again, reiteration, these programs will be available on the Hawaii Energy Office website. That was a pretty frequent question. And just regarding Justin's presentation, what's really heartening about that is they're reaching low-income people, and those are exactly people who should be reached, because energy takes a big chunk out of their total budget. And also, I believe, Justin, at the time you put these studies together, you were estimating a kWh cost of 30 cents. And due to world events, the average cost, to my knowledge, is 35 cents a kWh and even higher, meaning that any measures that are taken have a larger implication, larger savings, especially for low-income people. And we Energy Office people work with Hawaii Energy literally every day. Much appreciate their efforts. But maybe more questions will come in, but before that, maybe we should get, Eric, to the most important part of this entire presentation and bring to the stage Miss Karen Shishido.
Hi, Howard. Thank you so much. Thanks, everyone, for sticking around and for your interest in this topic. I have the fun job of giving away some food. Hopefully, everyone's favorite local joint, the Zippies. I did pick at random 3 names. One gentleman is not in attendance, so unfortunately, he's going to miss out. But the first person, and I'm not sure if you guys can unmute and just say if you're here or not, or we'll just maybe say all the names. But the first person to win a $25 gift card is Chris Kele or Keel, K-E-L-E. Chris, you're our first winner, so congratulations. We're going to send that to you I'll email the address you have on file on the registration and get that over to your house. A second person to win is Jessica Wiley, W-I-L-E-Y. Congratulations, Jessica. And the third person, I hope he's still on, is Benjamin Kandari, C-A-N-D-A-R-I. So those are our 3 winners, and stay tuned. The next session we'll have 3 more winners. So thanks. Yay, Chris is in attendance. And with that, I'm going to hand it back over to Eric. Thank you, everyone.
And then I'll hand it quickly back to Howard.
Well, you know what, Eric, let's keep you on board. We've got a few more minutes. Here's an interesting question. Can you briefly address existing structures and the implications of permitting and implementing a change of space conditioning? And the short answer is, if you're going from non-conditioned to conditioned spaces, that conditioned space needs to conform to the envelope requirements, the code envelope requirements. Do you want to add anything to that, Eric?
No, that's right. I know that in the existing code in a couple of the counties, there's some exceptions that are offered that allow you paths to not bring the envelope, for example, up to full compliance, but you'll need to check with the local county. But in general, it's a challenging thing because there are lots of structures in Hawaii that are not currently well insulated, and we may want to change the use and add AC. And so that does create a challenge to bringing it up to compliance. That said, we definitely don't want to be adding AC into a building that's going to have massive cooling loads because of, say, uninsulated roofs or poorly shaded windows and such. So there's reasons for that requirement.
Yeah, and this is a good time to put in a plug for ceiling fans. Ceiling fans work beautifully in Hawaii's mild climate, and they use about 1/20th as much energy as does a split system. Let's see, we have one last question. Can you please go over window SHGC compliance and including projection factors? And I answered online, but Eric, maybe you can explain it a whole lot better than I can.
Yeah, just kind of really quickly. So in residential, there's the tropical zone option and prescriptive option. If you follow the tropical zone option and you look at the checklist, you'll see that the bigger your overhang, the less window performance you need. So if you have actually a window projection factor of 0.5 or greater, which means that the distance that it sticks out from the wall is half of the distance from the bottom of the window up to the overhang, that's a projection factor of 0.5, you can have clear glass. You don't need any shading. And if you have smaller overhangs, you do have to face some requirements. That's all in the tropical zone option. If you have an AC building, there's not really any flexibility in the prescriptive requirements. It's a solar heat gain coefficient of 0.25. So
Hey, thank you, Eric. And what's, oh my goodness.
There was, yeah. So we could take this one last follow-up question about, does it matter which orientation of the building the overhang's on? Yeah, so in the tropical zone option, a smaller overhang will get you, will work on the north side compared to the other sides. And I think we'll have to take the other questions offline because we're coming right up to the end of our time here. But I do want to encourage you to check out workshops 2 and 3, and then the Train the Trainer workshop, if you're interested, that Sumi mentioned earlier on the 29th. And we'd also really appreciate your feedback in this evaluation survey. It should only take a minute or 2, and you can provide feedback on additional training that you might be interested in. Kiara's just put a link into the chat, so please check that out. And then I'll just hand it off to Howard to close this out.
Yeah, well, we're right on time for a closing, and most of you are scheduled to participate in our next 2 webinars. And this is we're getting great numbers, great participation from you. And this is going to speed up our path to achieving 100% clean energy for Hawaii. So we thank your participation in this very much. See you next week.